reviewing Algebra 2 stuff, but we just go a lot quicker than you did in Algebra 2 because you've learned it before, right? We're just trying to refresh that little mind of yours after a big, long summer break. So adding, subtracting, multiplying, and dividing. It's really exactly what it says. It's just kind of making sure you know the notation there. So like if you add two functions, they write it like this, but it just really means you add two functions. I'm just going to show you all these because I feel like it's not that exciting. We're probably looking at our chapter 1 test, maybe the end of next week or the beginning of the following week, depending on how long it takes to do all this. But we should hopefully get another test in before midterms come out. I'm not sure when midterms come out. Do you know? Is this the 4th week of school already? So probably really soon. We might not have another test yet. Well, halfway of the first 9 weeks. So really like, we got a while. When we subtract, we just subtract. When we multiply, we just multiply. The big one is dividing. When you divide two functions, you have to make sure that you say what the denominator can't be because the domain's going to be restricted if there's an x in the denominator. And we're going to practice doing that a little bit, probably a little more than you did last year. And you don't necessarily have to write all this if you want, but it says in each case, the domain of the new function consists of all the numbers that belong to both the domain of f and the domain of g. I always just say, like, a shortened way of saying that is, if the domain of f or g is restricted, then the domain of your sum, difference, or product is also going to be restricted. But the extra one is the quotient. Like, your domain will change if you have an x in the bottom on the quotient one. So we'll practice doing this, and I do want you to do the domain of these on your homework because it's good practice with domain. Okay with that? How was the pep session on Friday? I was kind of a terrible person and didn't go because it was my prep, and I didn't want to skip my prep and grade papers, and I felt awful. But Mr. McClure was on prep too, and we both felt awful that we didn't go. But I said, well, if we get in trouble, we'll both get in trouble together. Was it good? We felt bad because we heard it was going to be really good, and we felt like we were being terrible people for not going. But I had a grade and get ready to teach today. Okay, I moved on then. So let's just practice. We're just going to do one of these. We're just going to do all of them, though. Here's the great part. I don't know if your homework's like this or not. I think it is. Oh, yeah. The fun part of your homework is that they're going to ask you to do, like, all this in one problem, right? So it's like four problems in one. Okay. And notice they're not as simple functions. Last year when you did this in Algebra 2, a lot of times they were both polynomial functions. But this one, f of x is x cubed. G of x is the square root of x plus 1, and then we're going to add, subtract, multiply, divide, and give the domains of them for all four of them. So if you want to just do part A first, and then you can do part B underneath it instead of not having enough room. So if I'm going to add these two functions, I'm just going to add f of x plus g of x. And I like to do this one because people struggle more with ones that aren't like terms. Because when you add these two, do you agree that we get x cubed plus the square root of x plus 1? Sure. Can I add those two together anymore? Which means you're done with that part of the problem, right? So if there's like terms, if you had two x cubes, if you had two constants, right? If you had something you could add together, by all means add it together. But a lot of times they're not going to be very compatible functions in terms of like terms.
You have to write the f of x.
No, you really don't. But what I do want you to write is the domain. So let's go back and look at the domains of our original functions before we figure out what the domain of this new function is going to be. What is the domain of x cubed? All real numbers. It's a little S shape, right? It goes on. It's nothing weird happening. So the domain of this is all real square root of x plus 1, is it going to have a domain of all real numbers? The square root function ever going to have a domain of all real numbers? Nope, it's at half of a parabola. How am I going to know what is the smallest x value that I can plug in there? Because 0 is the smallest square root I can get, right? Like if you weren't sure, you can just set this equal to 0 and see what you get. It's just -1, and it's going to be everything bigger than -1, right? Does it include -1? So I would like bracket -1 to infinity. Since we're putting these two together, you have to take the restricted domain. Like when I add these two together, this is still all real numbers, but this is still restricted. So my domain is going to be from -1 to infinity, because that's what the domain of g of x is. Because no longer can I plug in everything. All right, and so for pretty much everything but division, you are going to just take whatever the restricted domain is, and that's going to go with the rest of them. If I subtract these, you agree again, I'm not going to be able to do anything. It's just going to be subtracting x cubed minus the square root of x plus 1. And my domain still going to be the same. What about multiplying these? X cubed times the square root of x plus 1. Can I distribute that x cubed inside that radical there? No. So again, you can't do anything. Some of the ones on your homework you really can. You're going to have to do a little bit of work. But I like to show you this one because you can't do anything. Is my domain still going to be restricted from -1 to infinity? Still going to be restricted. So as long as you got the domain right at the top, we should be good to go here. Now division is where you got to pay attention here, because we cannot divide by 0. So if I divide these two, which is the top function over the bottom function, so that would be x cubed over the square root of x plus 1. Is my domain going to change any from the other ones? Oh, what do you want to reduce it to? Oh, move the square root to the top. I'm okay with it in the bottom. But you're right. We could move it to the top if you really wanted to, but I'm okay if you don't. Do you want to move it to the top? How would we move it to the top? Yeah, I think we had to multiply the top and the bottom by the square root of x plus 1. Oh, so what did you say? Square it? Is that what you said? Kind of? Maybe we should do this. I think we should do this, right? It's kind of like squaring it, but you got to remember that you're doing the same thing to the top. Like you can't just square the top and square the bottom, because it's not an equation. You have to do this, because the square root times itself is going to cancel out, and you'd actually have x cubed times the square root of x plus 1, and then just x plus 1 on the bottom. You with me on that? Like you move the square root to the top. Like just if you have like a square root of 3 on the bottom, you multiply the top and the bottom by the square root of 3. I'm really okay if you didn't simplify it, because it's not really that big of a deal right now. But this is what we would get. This might help you with your domain now. What can't x be now? What's the extra thing that x is not allowed to be? -1, right? Like it can't be 0 in the denominator. So if you see a denominator, you have to say, this is not allowed to equal 0, right? So how does my domain change? Is it just x can't equal -1? Yeah, I think it should be this. Because it's still restricted, because we still have a square root, even though we moved it to the top. You still can't have a negative under your radical. But the extra part is, you can't include -1. You can take the square root of 0. That's why it's included up here. But you can't divide by 0. So if you have something in the denominator, your domain is going to change. So make sure you pay attention to that. All right? So denominators with x in them and square roots. Those are our big things that are restricting our domain. Okay, so I'm not going to do much more with this, but I'll let you do some on your homework. The other thing I want to remind you of today is functional composition. Remember last year you learned about functional composition, and it's actually a new operation. It's not multiplying, it's taking a function and putting it into another function. And it's this little open circle. That does not mean f times g. It also does not mean the word fog. It means f of g. When we read this, we say f of g of x. And I always say you can replace that little open circle with a set of parentheses. And so that's why I wrote it like this. This is the same as this. If you just replace that with a set of parentheses and close it, and that means taking g of x and plugging it into f of x. It does not mean multiplying these two functions. So let's just try one of these. I saw the week before on Facebook someone posted that they won, and I didn't see anything, so I assumed that maybe that meant. F of g of x. So we're going to take, I always write like this, f of g of x. And if you struggle with this, remember to always work with your inside function and work your way out. So g of x is the inside function. So you can take what g of x is and just replace g of x with that function. That's what composition is, taking the inside function and plugging it into the outside function. And then now finding f of 2x, you should know that that means everywhere in f that you see an x, you're going to replace it with 2x. So I'm going to get 3 times 2x squared plus 2. Who has a question on where I'm getting all that from? No. I'm just popping your wrist. If you do that all at once, I'm okay with it, but that's how you can kind of break it down a step at a time. And then remember to make sure you follow order of operations. You should be taking your exponents before you multiply by 3. So this is really 4x squared, and that would just be 12x squared plus 2. That would be f of g x. Remember that order matters in this. It's not like multiplication. Like 3 times 4 is the same as 4 times 3. F of g does not necessarily equal what g of f does. So why don't you do that one? We'll make this one, this will be like part A. Now part B, I want you to find g of f of x. So now f of x is going in here, right? 3x squared plus 2. So all I have to do is replace that x with this, and I think we should get 6x squared plus 4. Did you get that? Remember, they can also ask you to find a number like g of f of 7. You could actually do g of f of x first, but do you remember, like, I'm throwing a third example over here. What if I said, actually, I want to make a whole new problem. Number 4. What if I said f of x equals x squared plus 3x minus 7 and g of x equals 2x plus 1. And I want you to find f of g of 7. Read that writing? You could just do f of g just like we did up there, and you get an answer with x's in it. But when it's a number, like I feel like it's easier just to work with your inside function and work your way out and just get a number answer out of it. So I want to make sure that you maybe kind of remember that. Right, so this is like saying f parentheses g of 7. So we start with the inside function. So can you do g of 7? What would g of 7 be? Yeah, because 7 times 2 is 14. 14 plus 1 is 15. Oh, you can tell I just made this up because this is a pretty big number now. And now you just do f of 15. And so you don't actually have to do the whole x's things if you just have a number there. And so now f of 15 is going to be 15 squared plus 3 times 15 minus 7, which is going to be an awfully big number. What did you get, Allison? 263. You're going to be doing that on your homework as well. Questions about that? Okay, our numbers are all really messed up now because I added extra. Something else that we do in this book that probably you didn't do in Algebra 2 is we like to try to make you work backwards, and we call it decomposing functions because this is composition, composing them. So now, what if they give you the composition and they ask you to break it up? And you could cheat every time and say that one function is just x and the other function is what you have there because that's what you get back. But on the test, I like to make sure I put that in the directions that one function is not allowed to be x. You have to make it two separate functions, more complicated than that. But what you want to think about is when you do a composition that you have kind of like an inside function and an outside function. And so once you do it a few times, I think that it becomes a lot easier if you can kind of look at that and see what's the outside function and what's the inside function. On this one, do you agree that like a square root could be like the outside function because it's like the outer part, and then this maybe could be my inside function? So what if I said g of x equals x squared plus 5, and f of x would have to be what? Yeah, the square root of x. Because if I took this and plugged it in there, I would get that. You see how I'm the whole decomposing thing? So let me make up another one since I did this one for you. This is really 4 now, right? I'll make this 5 now. What if I said h of x equals x squared plus 3 squared minus 1. So think about for a minute of how you could write that, like, you probably could see the inside function, hopefully, and then think about what the outside function, or f of x, would have to end up being. Let's go like this. Think you got it, Mason? What do you think? What do you think? Here, you tell me either one. What, g of x or f of x? Because that's kind of inside. If you see like a parenthesis or a square root, that's usually got ideas inside. So if that's the inside function, what's left as the outside function? Do you agree with that? Do you see that? because this could be replacing this. This is still left out there. There's a couple of those on your homework. I like those. People tend to struggle with them sometimes, so I wanted to make sure that we did a few of them, and we can look at them tomorrow. But the more you do them, the more that you see the inside and the outside. One last thing. An implicit equation are two equations that are put together. An implicit equation is not a function. What we're going to practice doing today, and eventually, I think the last section in this chapter is all about implicit equations that we're actually going to graph. We want to change it back to two different equations, like two functions that we know and that we can graph. And so it's kind of just like practicing some algebra here. And so the homework's going to say something like this. Describe the graph of the relation. That just means they want you to solve it back to two equations. And so we want to try to be able to solve for y, which sometimes can be a little tricky. If I asked you what the graph of x squared plus 2xy plus y squared equals 4 looks like, you might not be sure what it looks like because there's a whole lot of stuff going on there. But if we can solve it back for y, then it's going to be a lot easier to say, oh, this graph is made up of this and this. I picked a tricky one here. The ones on your homework either will be like this, because you'll have a nice example of it, or they won't be as hard to solve for y. But the hard part about this one is there's both a y and a y squared. Do you agree with that? So you might think, well, what if we move this x squared over here? If we factor a y out of that, is that going to get y by itself? Because that's still going to have a y there, right? So just like when you see an x squared and an x, and you can't just factor an x out of it, like if I give you something like this, if I asked you to solve this, we've done it enough that you know you could factor or complete the square or do the quadratic formula. But when you first did this, back in, I don't even know what grade, you're like, oh, I can't factor an x out. What are my options? What do I do? There's a problem when there's a squared and a first power there. So the same thing here. Do you see that this kind of maybe could be factored? If I gave you that hint there, can we maybe factor this? Let's try. And again, sometimes we do problems in class and people say, how in the world would I know how to do that? Well, that's why we do them in class, so you have an example to help you with. But do you agree to get x squared? We could just put x and x here. I made my parentheses awfully big. And to get y squared at the end, do you agree we could just put y and y? Since I have stuff in the middle, it's not going to be a plus and a minus. If I put a plus sign and a plus sign, if I FOILed that out, would I get back that x squared plus 2xy plus y squared? Right? So we get x squared plus xy plus yx, which is the same as xy, plus y squared. You with me on that? That's a sum of two squares there. But it does work. So could I write that as x plus y squared equals 4? Give me lots of hints here. And then what could you do to solve that? Yeah. If there was only a y in that, or even just a y squared, then you could just get it by itself, and you just square root both sides. But this one you had to factor. But now we could square root both sides. I'm going to come up here. And don't forget, when we square root both sides, we have to do plus or minus, right? Solve for y. We would get y equals negative x plus or minus 2, which actually just means it's two different linear equations. So like you could write it out as negative x plus 2 negative x minus 2. Describe the graph. I'm going to say it is two linear equations. Definitely would not be a function if we graphed both of those linear equations. That's a good one, right? So again, just kind of practicing your calculus skills on those last ones. Questions about that? All right, I think we're finally done. So homework 1-4. Note there, my directions there. We're not going to mess with the domain of the composition of functions, but I do want you to do the domain of the adding, subtracting ones. All right, adding, subtracting, multiplying, dividing, but of the f of g, g of f, you don't have to do the domain of those. So a lot of this homework is just that, and then